Okay, this problem is an estimation problem. We're asked to estimate the speed in meters per second with which hair on your head grows, and we're given some suggestions for how you might make this estimate. So let's go ahead and strategize. How are we going to set up this problem? Okay, the first piece of the puzzle is that we need to figure out an estimate for how quickly your hair grows. And if you're me, I cut my hair about once a year, and if you've ever seen the pre-lecture videos, you'll understand that makes some sense. And in 1 year, my hair grows by about 8 inches, okay? And we can actually express that as the speed because the speed is just a distance divided by a time. And so the distance is 8 inches, and the time is 1 year. Except this is not the way that we want to have it. We don't want it in inches per year. We want the answer in meters per second. So we need to do some conversion. And so the next step is going to be to take this expression right here for the speed. We have to convert that to meters per second. And to do that, we're going to do some preparation. So to prepare, what we're going to do is we're going to gather together the various conversion factors which we need to do this. And we know that 1 inch is equal to 2.54 centimeters. And we know that 100 centimeters is equal to 1 meter. That's going to be important. We also know some things about the time intervals involved. Okay, 1 year is equal to 365 days. 1 day is equal to 24 hours, and 1 hour is equal to 3,600 seconds. So that's our preparation. We've got all the conversion factors that we need to make sense of this and to finish our calculation. For a solution, we're actually going to do the conversion. And the way we're going to do the conversion is this. We're going to write down our speed. Okay, it's 8 inches per year. And we're going to multiply by a series of factors that are basically factors of 1. So we know that 2.54 centimeters is equal to 1 inch. So 2.5 centimeters over 1 inch is just equal to 1 because those numbers are equal to each other. But check out what happens. Inches cancel, and we're left with centimeters. And so we've converted our units from inches to centimeters, which brings us one step closer to our final result. So we'll just multiply by a series of factors. So we'll have 1 meter is equal to 100 centimeters, and we know that 1 year is equal to 365 days, and we know that 1 day is equal to 24 hours, and we know that 1 hour is equal to 3,600 seconds. So each one of these factors allows us to cancel a unit. Okay, so we're going to cancel centimeters and be left with meters. We're going to cancel years, and we're going to be left with days. And we're going to cancel days, and we're going to be left with hours, and we're going to cancel hours and be left with seconds. And so when we multiply all this out, we're going to get a speed in meters per second. And if we do that, we're told to express the result in scientific notation. So if we calculate this out, we get 6.4 times 10 to the minus 9th meters per second. And I'm going to express this to one significant figure. This is approximately equal to 6 times 10 to the minus 9th meters per second. And the reason why I've done that is this is a one significant figure problem. I only know the accuracy with which my hair grows to one significant figure at best. And so there's no point to claim two significant figures for a result. So this is about as accurate as we can claim. Let's assess and see if this answer makes sense. So we get 6 times 10 to the minus 9th meters per second. That's 6 nanometers per second. And I expect the speed to be very slow. I can't just sit there and watch it grow. It takes a year for it to add up to anything noticeable enough that I feel the need to go to the barber. And so my final result is reasonable. We expect a slow speed, and that is exactly what we got.